the instructions available for the machine control, stack, interrupt and I/O, input output in 8085 microprocessor. So let's start. So the instruction under this group, stack, this stack I/O machine control instruction includes the instruction for the I/O ports, instruction for the stack, instruction for the input interrupt, and instruction for different instruction for the machine control. That means to control the 8085. Now to start with this instruction, these groups, for the instruction for the input and the output. So suppose you are connecting one hardware with your 8085 from which microprocessor needs to read some data, and also to which microprocessor need to send some data. So obviously you can't directly connect the hardware extra circuit with the microprocessor, so you have to connect it through some port or port offering device. So the port to read and write, to read the data from the hardware, or to write data or to send data to the hardware, the instructions, there are two instructions, in and out. So in port, so this port is the 8-bit port address. Now remember, this port is the address of the hardware, but it is 8-bit, not 16-bit like memory address. This is an 8-bit port address of the hardware. And this data transfer in between the hardware and the microprocessor always takes in between the accumulator and the hardware, that is the port, not into any other register of the microprocessor. Remember, this is always in the accumulator. So in port means from that port, port is nothing but the 8-bit address or 1-byte address from that hardware specifying by this port address, data will come, 8-bit data will come into the accumulator. Okay, it can be written like this: the content of the byte 2 of the instruction is nothing but the port address, and the content of that port address or the port or the hardware data comes to the accumulator. So data available in the port is moved to the accumulator. So it's a 2-byte instruction, because in is the instructions for which there is an opcode, and port is your 8-bit address or 1-byte address. So therefore total of 2 byte. Cycle here is 3 and is the 10 addressing mode, direct addressing mode. Why direct? So data is directly transferred from the port to the accumulator, where the address of that port is given along with the instruction. So therefore it is direct data transfer. And it's a type of data transfer instruction, so therefore no flag is affected. In addressing mode there are 2 bytes, and in the instruction format the opcode is db hex. Similarly, output is if microprocessor sends data to the port. So where from you can microprocessor can send data? Only from the accumulator. So accumulator to the port. Okay. Same way, the opcode is D3 hex. So these two instructions are for handling the data transfer between the processor and the external hardware or the peripherals that you want to connect with your processor. Okay. So next is the second group, the stack manipulation instructions. Okay, so stack manipulation instruction, as in my previous videos I mentioned the purpose of the stack. Stack is nothing but a defined slot of read-write memory whose address is pointed by the 16-bit register called stack pointer. Okay, so stack is a stack of memory which is predefined. Of course, it has to be in the RAM, that is read-write, defined read-write memory. Okay, so to handling that stack, there is I'll make a separate video on it for the stack and stack related operations, where I'll actually explain all these instructions in detail. Here I am just mentioning and just introducing the instruction only. That is why I made it yellow here. Okay, I'll explain this because probably it would be difficult to understand without dealing with the stack to understand this stack related instructions. So basically there are these 6 different instructions for handling the stack operation in 8085. push and pop, XTHL and space. Push RP, this push RP, as you know, this stack is a defined slot of predefined slot of the memory RAM, okay, whose address is pointed by the stack pointer, and stack pointer works in a leaf order, last in first out. So you have to manipulate the stack pointer. So where you will ask? You will ask to the stack pointer, and stack pointer will say that this is the address of the stack where data is stored, stacked. Okay. So push RP means you are feeding the address, okay, to the stack pointer. So RP is the new register pair. So it will go to this higher byte of the address, higher byte of this register pair. Suppose it is a BC register pair, so C is your higher byte. So higher byte of this address, which is in the C, will go to the memory address whose memory location whose address is 1 less than that of the stack pointer. Lower byte will go to the memory location whose address is 2 less than that of the stack pointer, and stack pointer is decremented by 2. Why so? Because stack pointer always works in a leaf order. Pop RB is just the opposite of this push. So push means you are pushing into the stack pointer, pop means you are popping out from the stack pointer. Similarly, push PSW and pop PSW. PSW means processor status word. So processor status word means, or also called a program status word. So how can you define the status of a program or status of a current status of a processor? It always the status of the accumulator, because accumulator hold the result and the conditions or the decisions is on the flag. So processor status word at any point or the program status word at any point is the content of the accumulator plus content of the flag register. Together is called the processor status word. That means, or program status. That means after execution, if you look at the accumulator, you will get the result, and if you look into the flag, you will get the different conditions of the results. So together is the program status. So similarly, push as PSW, that means you are pushing PSW into the stack. PSW means accumulator is your higher byte, the flag is in your lower byte. Similarly, pop PSW. XTHL means you are exchanging HL with the stack pointer. SPHL means you are loading from HL to the SP. Here it is exchanging, here it is loading. Okay. So I am just introducing these instructions here at this point of time. I will make a separate video dedicated to the stack and stack related operations, where I will explain detail about this with programs and with different stack operations. Similarly, in the next category, there are instructions for the interrupt control. Again, it need to understand the interrupt, where different hardware interrupt, software interrupt available in 8085, and along with how it works, what is the priority, lot many things are there. So what I am thinking is to make a separate video on interrupt only, where I will explain all the detail about the interrupt procedure or interrupt service routine, which we call ISR, interrupt service routine, along with these instructions available in 8085. Here I am just introducing these instructions. So to control the entire set of interrupt in 8085, interrupt is something like, suppose you are working and someone is interrupting. So you are suspending your current task and executing the task given by the interrupt, and once that task is finished, then you are resuming your current task. That is the interrupt. Okay. So in 8085 there are hardware interrupt as well as software interrupt. Okay. So to control the entire set of interrupt in 8085, there are only 4 instructions, which are EI, DI, CMIN, RIM. EI means enable interrupt. DI means disable interrupt. Sync means set interrupt mask. Some interrupts are maskable interrupts, some hardware interrupts, some interrupts are non-maskable. Maskable interrupt means you can enable or disable. Means you can disable also the interrupt. Non-maskable interrupt means you can't disable it. Once it occurs, you have to execute it. It is something based on the priority. Okay. Read interrupt mask, that means to read that mask. Okay, so I'll not go through detail right now about these 4 different instructions, while I'll make a separate video on the interrupt and interrupt detail about the interrupt in 8085. There we will explain these instructions. Next is the 4th category is the machine control instruction. So there are 2 instructions to control the machine in 8085. First one is knob. This is although this instruction does not do anything, but still it is important. Knob. Knob means no operation. It does not do anything. No operation is performed in this instruction. So sometimes what we need to do is sometimes we need to make the processor busy or busy for some nothing. That means sometimes we need to make the processor to wait. Okay, within a program. So in that case, we'll use this knob, because this knob does nothing, no operation is performed, but still it has one machine cycle and T-state 4. Once it is T-state 4, so while executing this instruction by your processor, it will take 4 into 1 T-state, that is in 8085 it is 3 megahertz, that is 0.33 microsecond. So 4 into 0.33 microsecond means 1.32 microsecond. So while executing knob, microprocessor takes 1.32 microsecond, but it does nothing. Okay, so that means microprocessor is waiting or busy for 1.32 microsecond, but busy for nothing. And interestingly, for this instruction, the first instruction is, or the first output is this 0 0. Similarly, to stop a program, the instruction is halt, HLT, to stop. When this instruction is executed, any further program execution is stopped. The microprocessor remains in halt state, and interrupt or reset is required to exit from the halt state. So once the microprocessor enters into the halt state, it can be exit, or means microprocessor can be exit from the halt state with either interrupt or a reset signal. Okay, and this is also 1 byte instruction, machine cycle 1 T-state 4, and opcode is 76 hex. Okay, so these are the 2 machine control instruction: NOP, no operation, and halt, to stop. 4 instruction for controlling the entire set of instruction: enable interrupt, disable interrupt, set interrupt mask, or read interrupt mask. In my separate video on interrupt, I will explain all these things. Then stack related instructions to control or to operate on the stack. There are 6 instructions: push RP, pop RP, push PSW, pop PSW, XDHL, and SPHL. Okay, in my in a separate video, I will explain detail about the stack and stack related operation. There will describe these instructions. Then for handling the external peripherals, or to data takes place the data transfer in between the external hardware, there are 2 instructions: in port, where port is an 8-bit address, and out port. In port means reading data by the microprocessor from the hardware, and output means writing data to the hardware. Okay, this is for I/O handling. Okay, so with this, let's stop here. Okay, if you find any difficulties to understand, get back to me. Thank you for listening. Thank you very much.